Perfect. Do we know what makes them similar? They do have similarities. One thing about similar triangles is all of the angles are congruent. What does that mean? It is. It does. Why didn't I just say the same? Okay. And then let's just say all. All angles are congruent, so that means they're the exact same. And all sides are increased or decreased by the same ratio. Okay, so what I mean by that is if I have a triangle, a small triangle, and the sides are 2, 3, and 3, and then I have a big triangle that I state is similar, and has a scale factor of 2, that would mean that I times all these sides by 2. So this would be 6, 6, and 4. And they all have to be increased by the same ratio or decreased by the same ratio. You can't have this side increased by 2 and this side increased by 3. They wouldn't be similar then. So when we say something similar, those are properties that they share. Okay, okay, that was grade 9? 8? 6? Sure, whatever. It was one of those grades. I don't know. You did basic algebra. You would have done some fractions. And you would have started talking about positive and negative numbers. Sounds like a good time. Okay, the point, P theta lies on the intersection of the unit circle and a line joining the origin to the point 4, 3. Find the coordinates. So looking for the xy's of P theta. Okay. This side. So does 4, 3 lie on the unit circle? No. Because what do we know this distance is? 1. What do we know this distance is? 1. Right? So if it's 4, that means it's going to be outside the unit circle. So we're going to have a point somewhere out here. That's 4, 3. So I'm just creating this triangle here. So what do we know about the base of this triangle? It has a length of 4, and it has a height of 3. You guys are so smart. Okay, I'm going to go purple. Now let's look at the triangle that's on the unit circle. So what we're trying to find is this purple XY here. We're trying to find that point that lies on the unit circle. So this triangle, this purple triangle here, has a height of what? Do we know? We don't. We don't. We don't know what it is. So we would say it's a height of Y. And what's the base of this triangle, the purple triangle? S. What's one thing we do know about this triangle? What do we know the hypotenuse measurement is? 1. Okay, now the red triangle, what's the hypotenuse measurement of that? It's Pythagorean triple, right? 3 squared plus 4 squared. So 9 plus 16 gives me the root of 25, which is 5. So I knew that the hypotenuse measure on this is 5. Are you excited? So all we're doing is ratios. we know what did I say was the premise of similar triangles was that they have to be the same ratio. So if we know that the hypotenuse of my big triangle is 5, I know the hypotenuse of my little triangle is, right? And that has to be equal to the big triangle. Let's do the x first. The big triangle measurement is 4. And what's the little triangle measurement that's on the similar side? Is that an x or a y? What's the 4 represented? Is that an x or a y? X. So what am I going to compare it to? The purple x, right? Super easy. How do we deal with fractions with equal signs? Cross multiply. So x times 5 is 5x. 1 times 4 is 4. Divided by 5, divided by 5. X is equal to 4/5. Guess what we have to do? We have to do it again for the y coordinate. You can't do x and y all at once when you have two variables. You can't solve for them. This is the ratio that's going to help you all the time. So we know in our big triangle it's 5. In our little triangle, the radius is 1. That's equivalent to, in the big triangle, we're looking for y now, so it's going to be 3. And in the little triangle, it's going to be y. Now, something very, very specific, I keep big O on the top and small O on the bottom. It doesn't matter, just as long as your triangles stay on the same level. That makes sense, everybody? So big on top, small on bottom, you're going to get the exact same answer if you put small on top and big on bottom. So this is going to be 5y equals 3 divided by 5 divided by 5. Y is equal to 3/5. So what's the coordinate pair? 4/5, 3/5. That's exciting. But you can also do it another way. What do we know about the coordinate pair in relation to sine and cosine? What's the x? Is it cosine or sine? Cosine, right? Alphabetical order. Cosine then sine. So, using this big red triangle here, what's cosine of the angle theta? What is it? Yeah, red triangle. Or what's the sine of the triangle? Anybody else see the connection? Same thing. So you can do it either way. But the similar triangle part, you can do ratio.
Why would we not?
You don't know anything about similar triangles? Okay, it's all just math, but I feel a little like attacked that you don't remember how to do this. Okay, well then, do this. Okay. Wow, that was harsh. The point P theta lies on the intersection of the unit circle, and the line joining the origin to the point -3,6. Find the coordinates. And since you don't want to do similar triangles, we'll do it nice and easy. Where's -3,6? What quadrant? Quadrant 2. Did you draw it in quadrant 1? Yeah, that happens. I forgot my circle. It's kind of important. So with this red triangle, I'm going to have -3, +6. Theta is right here. So we have to find the hypotenuse. That's going to be the trick. So we're going to have -3 squared plus 6 squared equals hypotenuse squared. So 9 plus 36 equals c squared. So I'm going to have 45 equals c squared. Now, some of you may be tempted to leave it as root 45. Why would that make a teacher sad?
It's not in the simplest form, right? So you need to simplify your radical here.
That's a half mark deduction if you leave it like that. You remember how to simplify radicals? I feel like I write you a great deal. So 45, we're looking for the factors of 45 with the biggest perfect square in it. You could have done 3 and 15, but 3 and 15 has no perfect square. So 9 and 5, so you would take the square root of 9 and the square root of 5. Can I take the square root of 9? Yes. What is that? 3. Can I take the square root of 5? Not easily. So we're just going to leave it as root 5. Okay? So you simplified radicals. It was terrible in grade 11. Put some letters in there and all those to Helen and Hanbeck. Okay, so since you don't like doing similar figures, what am I doing now? Cosine and sine. So cosine of theta is equal to adjacent over hypotenuse, which I found to be 3 root 5. So -3 over 3 root 5. Want to simplify that? Yeah, you have to. -1 over root 5. And then sine theta is going to be 6 over 3 root 5. So sine of theta is equal to 2 over root 5. Should I make you rationalize them? No, you don't need to, and you don't do it on the provincial exam. Does it come in handy later in calculus? Rationalizing? Yes, I'm pointing at you, Kevin. Yeah, yeah. Just say yes. Pretend like you were present. All right, so you don't have to rationalize. I will not deduct marks for non-rationalized denominators, unless it specifically states to rationalize the denominator. You okay? Yeah. You okay? So this is way easier doing sine and cosine rather than similar figures. Okay, fair enough. So, oh, I guess we should list it as a coordinate pair because I need to see that you understand which one comes first. So the coordinate pair would be -1 root 5, comma 2 root 5. So you need to list it as a coordinate pair because that's the question asked for. Page 2. How to find the missing circular function for theta when one function is given. Good job. Identify the quadrant. Use the ratio to set up the triangle. Solve for the other ratios. Easy peasy, right? Okay. First of all, when I say solve for cos and tan, I want it listed as a fraction. I don't want you to use the second function button on your calculator at any point. So I'm asking you to solve for cos theta. I'm looking for something like that. I don't want you to actually figure out what the angle is. You get this up all the time, and I'm not sure why I want to do the extra step. Okay, so I've given you a restriction. This is step one, identify what quadrant you're in. What quadrant is that? Yeah. How much? Okay, just about, just for bragging rights. Just to say. Anybody? Everyone? Had you bet? Okay, so if we were to put this on the unit circle, we know that this is 2 pi here. We know this is pi. We know this is half of a pi. And this is 3/4 of a pi. You're like, I had no idea that that's what it was. But that is what it is, and that's what you have to know these things. So it's saying that theta has to be greater than or equal to 3 pi over 2, and it has to be less than or equal to 2 pi. So it could be on the y-axis, or it could be on the x-axis, because it includes both. They do that a lot of the time. They'll remove this one, and one of your answers will be 2 pi. But you can't include it because 2 pi is not included in your restrictions. So watch your restrictions. So it's saying, all right, I'm in quadrant 4. And I've got a bigger triangle. So let's set this up. So sine is opposite over hypotenuse. Just put the numbers on for right now. So where does the 3 go? Right there, perfect. Sine theta is opposite over hypotenuse. So opposite would be the y or the x. The y. So this would be a 3. Where would the 5 go? It's your hypotenuse. Now I'm going to put that negative on there. So would the negative be with the 3 or the 5? So just FYI, hypotenuse is another negative. Think knowing that little tidbit of information. What's the other side I need to solve for? That x value, right? What is it? 4. It's Pythagorean triple. 3, 4, 5. Now, is it a positive 4 or a negative 4? Positive. Why? Because you're in quadrant 4, and in quadrant 4, x's are positive, y's are negative. That's exactly what you said. Sorry, I was just speaking louder, so the video here. So now I want you to solve for cosine tan. Once I've done that, super easy. Now I can do my ratios. So cos of theta is equal to the adjacent side over the hypotenuse. So 4 over 5. And tan of theta is equal to opposite. So negative 3 over adjacent positive 4. You good? So pretty easy. Identify the quadrants, solve for the end of the side, and then solve for your trig ratio that it's asking. Oh, this is exciting. Rotations. Right? We're going to rotate it around the origin. All right. So first thing we have to do, nope, let's plot the point we're going to rotate. Ooh, move your paper around. I love it. These overheads and things. Yeah. And did it help? Perfect. I don't know if that's it. But I might be able to. We'll see. Okay. We'll see what I can do. So, all right. Well, obviously I can't even draw a coordinate plane. So, all right. So if I put this on, what do we know about our triangle? we know that cos of theta is equal to 1 over 2, and sine of theta is equal to root 3 over 2. So with that information, what do you know about my point? Okay, what's my hypotenuse measure? Let's try that one first. So, what's my adjacent measure? 1. And what's my opposite? So that's the triangle you have. Okay, so now it's saying if my angle's there, what am I doing to it? Theta subtract pi over 2. What am I doing? I'm moving it 1. Okay, I don't know what we're rotating it in which direction? Counterclockwise or clockwise? Clockwise, because you're subtracting it, right? So it's going to end up, if it's in quadrant 1, if I was adding, I'd move into quadrant 2, right? If I'm adding 90 degrees, I would be continuing on in this positive direction. I'm subtracting, so I'm going to go clockwise this way. You need to convert, this is 90 degrees. Right? Yes? So if I were to rotate it, you guys told me I had to change my page. What am I doing? Not a visual learner. So I'm rotating it this way. So what happens? I'm going into quadrant 4 for sure. Awesome. Okay. Okay. So now this line is moved 90 degrees. So this here should make 90 degrees. So 2 now rotates to here. What else changes? Root 3 actually doesn't. You're taking this triangle and you're rotating it this way. So if this rotated, you really need a piece of paper. Okay. We're doing arts and crafts. I don't think I can do it technology-wise. Hey, Miss Thompson.
Miss Thompson.
Miss Thompson. How did you do rotations? They're telling me you flipped the page. Oh. So, okay, this is here, and then we're going to rotate it 90 degrees. Negative 90. So now 2's here. Where's my root 3? Where did my root 3 go? It was the y, now what is it? The x. And my 1 was the x, and now it rotated to the y.
So now it looks like this. Right?
So essentially I've rotated. So I've rotated my triangle that way. Like I've taken it and moved it here. But here's the thing, is we don't do reference angles against the y, right? We always do them against the x. Right? You guys remember that? Yes. Talked about that in grade 11. So, what's the height of this triangle? It's 1. What's the width of this triangle? It's root 3. So all I've done is I've taken my triangle that was here, the green one, and I've rotated it 90 degrees, so it's sitting this way. But I never do my reference angle off the y-axis, I do it off the x. Okay, moral of the story, every 90 degrees, every 90-degree rotation that you do, you flip the x and the y. Just because
that's memory.
I tried taking similar triangles today, and I got called out for it because that's not how we do it.
Yeah, if you notice, it all does, it switches, and if you do 100 maybe, it'll still, the ratios will still be the same.
So for every 90 degrees, we flip your X and your Y. Okay. So now we're in quadrant 4. So what do we do with our X and our Y? We're going to switch. So if I did this, opposite is, well, so it's going to be root 3 over 2 and negative 1 and 1/2 because I'm in where? I'm in quadrant 4. Right? Oh, Ms. Thompson, while you're here, Aria, did she come see you? She wants to write the Waterloo. Grade 12. Aria starts with a J. J. She just came to see me today about it. And I didn't know if we had finished registering. No, she was in my grade 11 last semester.
She wasn't in my class. I don't have a person named Aria.
Oh, you know what? Maybe she's looking to write. So there's no Aria on our current Waterloo list?
I don't know, that would be,
Okay.
is she in grade 11?
She's in grade 11. Not in
Well, she is not for doing the next list.
Okay.
So it would just be a matter of nobody shows.
Okay. If she comes your way. Okay. All right. So now, same point. So back to the green. We're adding pi. So which direction are we going? Counterclockwise or clockwise? Counterclockwise. We're going this way now. So we rotate once. What happens to the coordinates? They switch, right? If you go 90 and then you go another 90, what happens? They switch back. Right? But the signs change. Now I'm in quadrant where? 3. 90 gets me to 2. Another 90 gets me to 3. Think in 90s for this one. So that's 2 times pi over 2. So first rotation, they'd switch. Second rotation, they'd switch back. So my coordinates would be 1/2 and root 3 over 2, but I'm in quadrant 1/2. 3, so negative. Do you want to draw the picture? Do you want me to draw the picture and flip around for you? You did? You guys just know that you got to flip around now? Perfect. Oh. I added this in because Mr. Dada taught me this way of remembering it, taped to my desk, so I thought I'd share it with you guys. What is sine? Sine is my y value of pi over 6. Sine pi over 6. Okay, so when I think looking to my head, I think, okay, 30 degrees, that is a short y. Like that's a short height, it's a longer x. We did that, right? So we know that that's a short y. So we know that cos at this angle would be, it's the other one, root 3 over 2. You only have 2 options. Okay? What would tan be? Okay. What is tan? Tan is adjacent over opposite, so that would be y over x, which would be sine over cos. Woo. So if you do this math, probably not in your head, but if you say 1/2 divided by root 3 over 2, what do you get? 1/2 times by 2 over root 3. I'm gonna expect that you guys know these. Remember. Okay, let's hop down to 60. Let's hop down to 60 here. What sign? What's y? What's 10? Okay, what is a quarter? Root 2 over 2. Root 2 over 2. 1. Okay, so this is how buddies help me remember my unit circle. Buddies, not like those over there. Okay, so 1, 2, 3. 3, 2, 1. So if you can remember them, if you can remember sine goes 1, 2, 3, and cosine goes 3, 2, 1, and these go in order. 1/3 is the smallest decimal. 1 is the next biggest number, and the root of 3 is greater than 1. They go in order. They go in magnitude order. Helpful, not helpful? I found this helpful, kind of just to remind me. Sine, 1, 2, 3, cos, 3, 2, 1, tangent. They always go in order. 1 over root 3, 1, and then root 3. They're in ascending order. So that's my little handy dandy coin data thing. If you know all of these, you can do if you can do the first quadrant, you can do every other quadrant based off of those.